since we know you're going into geometry, then let me give you an example of where you're going to need to use algebra and geometry. Okay?
Okay.
So let's assume you had a triangle and you wanted to know the area of that triangle. Do you know what area of a triangle is equal to?
Isn't it length
1/2 base times height. There's the base, there's the height, and that's the area. Okay, so if I had a base of 3 and a height of 4, the area would be 6. You with me?
Mm-hmm.
Okay. Now, the kind of problems you're going to get in geometry are going to look like this. They're going to tell you the base is a variable, and that is x minus 1. And they're going to say the area is 6. Figure out what x is. And this is where we use the algebra. In other words, this is a combination of geometry and algebra. You're going to learn all kinds of formulas in geometry as to what the area of a triangle is, what the area of a circle is, what the circumference of a circle is, things like that. Okay?
Okay.
But a lot of those problems need to be solved by using algebra. So let's go into this equation that I know is true, that the area of that triangle is 1/2 the base times the height. And let's put in everything they've given us. Well, what's the area?
6.
What's the base?
X.
What's the height?
X minus 1.
Now what we have to do is solve that equation. And we'll know what x is. And notice that because I have an x times another x, it's going to be a quadratic. Okay? So I'm going to have to use all of the things we've learned, which is factoring, solving equations, things like that. What's the first step here?
I would do FOIL.
Okay. Let's get rid of this half. I'm a huge believer that you want to get rid of fractions first. How do I get rid of that half?
Divide by 1/2 or multiply by.
It's better to think about it as multiplying by 2. Okay? And the reason is that what I have going on the right side here is being divided by 2. I didn't write it quite that way, but I could have. In other words, the exact same thing is to write it like this. That means the same as the way I originally wrote it. And if I gave you this equation, it makes really more sense to think about it as multiplying both sides by 2. But that's the same as dividing by 1/2, as long as you understand that. Okay? So the next line I'm going to write over here on the left is 12 equals x times x minus 1. And now let me start erasing some of this stuff so that I can finish this up with some blank space. How do I solve that?
Distribute, maybe?
Okay, that's a good first step. 12 equals what? other words, get rid of parentheses, right? Get rid of
Yeah.
parentheses, get rid of denominators. It's hard to go wrong by taking either of those as a first step.
X times X, I'm guessing would just be X.
No.
X squared?
Times X, what do you do with the exponents when you're multiplying the base?
Add them, so it'd be X squared.
Yes. Now what's X times minus 1?
Negative 1X.
Okay. So this equation becomes this. And now notice that we're looking at stuff that looks very similar to what we've been working on for 2 or 3 sessions. How do I solve this? It's a quadratic. When I'm solving it by factoring, by quadratic factoring, what do I want one side to equal?
0.
Okay, how do I get one side to equal 0?
Subtract 12.
Okay. Now I'm getting it closer and closer to something that looks really familiar. That's a quadratic. I can factor that. I've taught you how to factor it. I made it a little extra tough, but let's go through the steps of factoring that. First step.
X and X.
Second step.
Minus and minus.
How can you possibly produce a minus 12? You don't do it with 2 minus signs. That would produce a plus.
A plus and a minus sign.
Has to be. One has to be plus, one has to be minus. And in this particular case, because the coefficient of the x's is the same, plus minus is the same as minus plus. So I'll just pick either one, make it like that. It's the next step. Third step.
It would be
Verbalize it.
the factors of 12
Okay.
that subtract to X.
Not to x.
To 1, maybe?
1. To the coefficient of that middle term. Not to that middle term. This throws a lot of people. Because for one thing, the coefficient isn't written. I did not put a 1 there. If that was a 3, you'd have said factors of 12 that subtract the 3, right?
Yeah.
But the fact that the 1 is not written throws people off a little bit. So just remember that whether that thing is written or not, what you're doing is looking for factors of 12 that, in this case, subtract to the coefficient of the middle term, which is 1. And I don't even care about that sign yet. So what 2 factors are there of 12 that subtract to the number 1?
3 and 4.
Which goes where?
The 4 would go with the minus sign and the 3 would go with the plus sign.
Now give me this solution. There's 2 of them. If x plus 3 times x minus 4 is equal to 0, then what are the 2 values that might be possible for x?
Negative 3 and 4.
Okay, perfect. So that's the answer to the quadratic. But this is a geometry problem. When you have a triangle with dimensions, you can't have negative dimensions. There's no such thing. So one of these solutions is not valid. And it would be the negative 3. Because there's no way this base can have a dimension of negative 3. When you're dealing with geometry, all dimensions are positive. There is no such thing as a negative dimension. Okay?
Okay.
So, and remember what the rule of algebra says. The fundamental rule of algebra says if you have two things multiplied together that equal 0, one of them has to be 0. Doesn't say both of them have to be. It just says one of them has to be. So in this case, I'm going to put an X through that because that one makes no sense, but 4 does. So X is equal to 4. Well, now let's check. If X is 4, X minus 1 is 3. What's the area of that triangle?
6.
Perfect. We did it right. I would now stake my life on it. Okay? So, we started out with a geometry problem, but you can see that 90% of it was an algebra problem. So, geometry is really at least 50% algebra. So don't feel like you're wasting your time with us continuing to go on in algebra. And I do think for the moment that's the best path we have. Tell me what's going to happen here. You said you're signed up for the geometry class, right?
Yeah.
Not the honors geometry?
So before I was signed up for algebra honors,
I
I
remember.
yeah. So then I convinced them to sign me up for geometry, and now my schedule's geometry. So
But it's not honors geometry.
no.
I'm kind of glad.
Yeah, me too.
Only because there's a Mr. Yansak that teaches honors geometry. He's the only one that teaches honors geometry, and he's really tough. Most students have a real difficulty with him. So I hope that you do not get him. I don't know if he teaches regular geometry or not at Chatfield, but hopefully you'll get somebody else other than Yansak. But even still, tell me what else is going to happen. You're going to take geometry and just that'll be it? Or are they still going to give you a test that you have to pass to continue in geometry?
As far as I know, I just am in the class and I don't have to do anything.
And what all geometry classes do is they spend a week or two refreshing their students on algebra. Okay? So
Okay.
you'll definitely get a lot of algebra questions in your first week or two before you get into geometry. And I have a lot of good geometry stuff I can kind of help you with. If we happen to get through everything on this algebra material here, I can get you started on geometry, which will give you a little bit of a head start and be helpful to you. They don't really like the way school systems teach geometry. They kind of get you started on really tough material like proofs, and it tends to demoralize students. And there's no need to start on proofs, but they will. So you'll need help probably at the beginning of your geometry, and then just trust me that it gets easier after that.
Okay.
So try not to get too demoralized if they start you on proofs.
Got it.
All right? Okay. So that was our geometry problem for the day that used algebra and geometry. Now, let's begin new material, characteristics of quadratic functions. We talked about that last time. You know what quadratics are. They have x squareds in them, right?
Yep.
That's pretty much all you need. And you need no x. In other words, this is not a quadratic because it has an x that's to a fractional exponent. So quadratics are anything that has an x squared And then you can have an x and a number, or you can not. In other words, I could also just have x squared equals 10. That's a quadratic. As long as I have an x squared, I can have an x and I can have a number. But I cannot have an exponent other than 1 or 2. With me?
Yep.
That's the definition of a quadratic. Now, characteristics of quadratics. The biggest one is what they graph as. What do they look like? What's it called?
A parabola.
Yeah, and parabolas that either do this or do that. In other words, they either point up or they point down. And that's it. That's not a quadratic. It's got to be a parabola. All quadratics will be parabolas. Now, let's talk about something very simple. What determines whether it points up or down? Well, if I have a plus sign in front of the x squared, that points up, regardless of anything else. In other words, that implied plus sign means I'm looking at that kind of a quadratic. I'm not saying that that's where the graph should be. I'm just saying that if you want to know whether a quadratic points up or down, it's completely dependent on what that sign is. If I put a negative sign in front of that, it points down. Okay?
Okay.
All right. Now, where is the quadratic? In other words, graphing quadratics is actually a pretty big subject. Well, let's start. This is kind of like factoring. Factoring, you'll remember, was a big subject. We spent at least an hour and a half, maybe 2 hours on factoring. Well, graphing quadratics is going to be that kind of subject, okay? There's basically a few things you have to memorize. One is vertex format. This is the most common format for a quadratic. And here, I didn't really write this properly. Let me do this. It's always y equals, but that's vertex format. Now, what does vertex format mean? And let me give you an example. Y equals 2 times x minus 3 squared plus 4. Okay? So there's a quadratic function, and you can tell it's going to be a quadratic because if I were to expand that out, I'd have an x squared and I would have some number of x, and I would have a number. So it would end up fitting the definition of quadratics. Why is it called vertex format? Because h and k are the x and y coordinate of the vertex. The most important part of a parabola is that vertex. That vertex almost tells you 90% of everything you need to know about that parabola. Okay? It is without a doubt the most important point. So if h and k are the coordinates of the vertex, there's my vertex. Where is that? Based on this formula right here. What's h?
H would be 3.
What's k?
4.
Okay, now I go to my graph. I go over approximately 3. I go up 4. There's my vertex. 3, 4. Okay. Now, notice that the coefficient in front of the x squared term is going to be positive, not negative. That's not a negative 2, that's a positive 2. Which tells me that this parabola opens up. There it is. Notice that once I found the vertex, gosh, I was almost able to exactly draw the parabola. So vertex formula is a wonderful formula. A wonderful format. Now, let's change it just slightly. Let's make that a negative 2. Now what I know is that my vertex hasn't changed. My vertex is still at 3, 4. But the fact that that's a negative number in front of the x squared term means that this parabola is going to open down like that. Now, when it opens down, let me restate that. When it crosses the x-axis, you notice the first time I drew it, it went up, right?
Yep.
Which means it never is going to cross the x-axis. But if it does, in other words, if the vertex is above the x-axis and it opens down, or if the vertex is below the x-axis and it opens up, then it's always going to cross the x-axis in 2 spots. And they want you to know how to figure out those 2 spots. Okay?
All right.
So, how would I figure out those 2 spots? In other words, 3 points determine a quadratic. Got to have 3. The vertex is the most important by a lot, but you don't really know the full shape of a quadratic unless you have 3 points. And usually the 3 points they want are the vertex and the X intercepts. Okay?
Mm-hmm.
What's y when I'm on the x-axis? What's y equal to?
0.
Yeah. Key point in math. X-intercepts are where y equals 0. Y-intercepts are where x equals 0. So now I need to solve for the x-intercepts, and I'll be able to do a much better job of drawing this parabola. I know where the vertex is, but I don't yet know where the x-intercepts are. So let's go back to this equation, and I know that y is 0 when I'm on the x-intercept, right?
Yep.
So I substitute 0 for y. And now I solve that equation for x. And that'll give me my 2 values of x where I'm on the x-axis. Well, if I subtract 4 from both sides, I get minus 4 equals minus 2 times x minus 3 squared. Then what's the next step?
Distribute.
Actually not. I know that I've told you that getting rid of parentheses and fractions is usually the first couple things you want to do. But if you're looking for some that has a x that's being squared, there's an easier step. Let me just tell you what it is. If I divide both sides by minus 2, I get this. With me?
Yep.
Now, I could distribute that if I wanted, and then I would have a quadratic that I would solve. But there's really an easier way to solve this. What is it? What's the next step?
Factor?
Not factor. When one side that contains the variable is being squared, always tend to kind of think, take the square root of both sides.
Oh, right.
Right? So what do I get if I take the square root of both sides here?
So
What should your answer always start with? What words? Whenever you're solving, and this is the way I'd like you to remember it, whenever you are solving an equation by taking the square root of both sides, your answer must begin with the words what?
Plus and minus?
Yes. And I'm taking the square root of both sides, so it's plus or minus the square root of 2. And when I take the square root of the right side, it's just x minus 3. Now, what's the next step?
Add 3.
Yeah. Well, if I add 3 to that left side, here's what I get. 3 plus or minus the square root of 2, and that's what x is equal to. And when I get an answer like that, here's what it means. It means x is equal to 3 plus the square root of 2, and x is also equal to 3 minus the square root of 2. And those are two different numbers. That's one number. Square root of 2 is about 1.4. So the first x is about 1.6. Excuse me. That's the second x, 1.6. The first x is 3 plus 1.4, which would be 4.4. And so those are my two values. Those are my two x-intercepts, 4.4 and 1.6. So now I have a vertex, and I know the x-intercepts. I can draw a perfectly symmetrical parabola through those 3 points, and I have figured out how to graph that quadratic that they gave me. Now, you can kind of see that as long as they give you the quadratic and vertex format, that it becomes pretty easy because it gives you a very, very easy starting point, the vertex. That's where you want to start, always. And now is all you got to do is find two other points. So it was easy enough to figure out the x-intercepts by setting y equal to 0. And now once I've drawn 3 points, that's all you need. Now there are some teachers that will ask for 5 points. I consider that a little bit ridiculous. Only because 3 points determine a parabola just like 2 points determine a straight line. You don't need 3 points for a straight line. If you get 2 points, you got the straight line. Every other point has to be on that line. Same thing with a parabola. 3 points determine a parabola. And they don't have to be these 3. I could have the vertex. I could have another one there. I could have another one there. That would also determine that exact parabola. In fact, I don't even need the vertex. I could, if I told you that I got 3 points on a parabola, one's there, and one's over here, there's really only one parabola that can fit through those 3 points. And it would look something like this. But there's not 2. I cannot draw another parabola that goes through those 3 dots. So 3 points determine a quadratic. That's all you should ever have to draw in order to graph it, are 3 points. Now, I said this was a big subject. It is. We've just gotten started on it, but we're out of time. So I will let you go tonight, and we will pick up with graphing quadratics again next time.
All right, sounds good.
All right, Phoebe. Have a good weekend.
You too.
Bye-bye.
Bye.